All right, so right now we're going to talk about how to find extrema within the intervals, Now, first of all, we have to tell you what is extrema. I think the most literal way that without talking math is just pretty much the highest point. In the interval. And the lowest point in the interval. So when I say extrema, you're gonna say I'm gonna go find the highest point and lowest point. Now I'm gonna give you a graph and kind of illustrate that. So let's just say if I have some type of graph. What just happened? So if I have something like this. Now there are some points, major point happen. This usually called endpoint extrema or endpoint. So at this point here is called a relative min. And relative minimum means the function has to decreasing and increase. They can have a cusp. In this case, the relative minimum can have a cusp because basically just go down and come back up. There is a relative max and relative min. Now, this point is pretty special. This point is called absolute max. Absolute is in this interval is the highest. So let's say this is A and this is B. So in this interval, this is absolute max. There's no other point higher than this one. This one just an endpoint. That has nothing, right? It just an endpoint. It has nothing.
So where would the absolute minimum be?
Where do you think it is?
Would it just be the relative minimum in this?
Yep. Absolute minimum.
Yeah, so like relative minimum and relative min is two different things.
They are two different things because there is a relative minimum here, but they are not absolute. So absolute is the lowest point of them all. So absolute can happen at endpoint. It can happen at relative minimum. Okay, so it can happen at both. Now, if you realize here is what? What does this call? What does this C call? What does that C call?
Critical figure.
Critical what?
Critical
number.
Yeah.
Critical number. So that is the part of here. Good job. So that's critical number there. So that's very, very important understanding for you is critical number. Okay, so this is an absolute maximum. Okay, maximum. So absolute maximum, absolute minimum. So the absolute maximum is the highest point. So also known as the extrema here because they are the highest point. And extrema here, lowest point. Okay. So what is nice thing is this is you can use this and to find out all the absolute maximum. Now, how do I find it? So how to find extrema with an interval? within closed interval. Closed interval. Okay, it has to be close. So first, you have to find critical number, because critical number can tell you a possible max and min. So critical number. So you guys already know how to find critical number, right? There are two things, right? F prime of x equal to 0 or f prime of x equal to undefined. 2. Evaluate. Why do you need to evaluate? Because we don't know the y value. We're comparing the y value. See which one's lower and which one's higher. Evaluate critical number, because that's your relative max and min. And if you evaluate, then you can say, well, this is my output. I compare all the output and I see which one's higher. 3rd, evaluate endpoints. So there are two endpoints in the interval. There were left endpoint and right endpoint. Evaluate those. Find a y value, right? 4, compare. Compare end state, the maximum, so absolute max and absolute min. And the best way to compare is use a table, the T-chart. You guys remember the T-chart, right? It basically x equal to 2, y equal to -2, x equal to 1. So a T-chart. So like this. Now one more thing. If we ask you where is absolute max occur, usually means x value equal to question mark. Now if we ask you what is absolute maximum, and I'm gonna color this value. So when I talk about value, that means y value. Okay, that means y equal to only one number, not a coordinate, only one number. This one you can put as a coordinate if you want to. You can put something like this. That's fine. But if I ask you what's maximum value, it's the output. I just want to know what is the highest mountain in the world. Well, how high is the highest mountain in the world? You're gonna say it's Mount Everest. I don't know how tall is it. I think it's 8,000 feet or something like that, or 12,000 feet. How many feet is that? Meter? Really? Oh, I don't know. I could be wrong. I thought it was like 12,000. I thought maybe I was thinking about meters. Yeah, I think it's about meters. Either it's 8,000 meters or 12,000 meters. I don't remember. Yeah.
The first one up a little bit. It says f prime of x equals
0 and undefined.
yeah, so I just like the only answers.
There's only critical number. Yeah, and thanks for Gay. It should be critical numbers. How tall is Mount Everest? How tall is it? Huh? How tall is Mount Everest?
30,000 feet.
And how many meters is that? 12,000?
It's like 8,000.
Oh yeah, so I remember 8,000 something. Was meter of feet. No difference. That's kidding. I don't remember my facts. Okay, so the way to kind of think about it, how do I know value is if I ask you value, just make sure that you draw a small line on the bottom. That means YU. So that way you know I'm asking for Y value instead of X. So if I ask you absolute maximum value, that's going to be like this. Questions? Now I'm going to go to an example and you guys are going to give it a try. And the best way to justify is a table. What I mean by table is just the X, Y values. So I'm going to give you this question says f of X is equal to 3x to the fourth minus 4x to the 3. And what I mean by table is like this, right? X and Y, X and f of X, and just list down the endpoints, right? Endpoints, which is, in this case, is going to be, sorry, I'm going to give you endpoint between -1 to 2. So, of course, you're going to have to list down the -1 and 2 here. And depending on how many critical value you get, so you're going to draw a t-chart, right? So in this case, you have a two critical numbers, two endpoints, and then two critical value. And then go back to plug in original functions. If you plug in original function, guess what? You will get all those here, and then you compare everything. You compare everything and see which one's the highest and which one's the lowest. You can address this is the absolute maximum and this is the absolute minimum. If you did it right, you should get two critical values, sorry, critical numbers. This is very quickly. You gotta learn how to factor the GCF. X equal to 0, X equal to 1. I'm gonna plug in X, 0, 1, and 2, and -1. So those are the value I'm gonna go look for. What happened at -1? 7. What happened at 0? 0. What happened at 1? -1. What happened at 2? 16, right? So where's the absolute maximum? This is the absolute max. And this is absolute min, right? Remember, if I would have asked you what is absolute min, what are you going to tell me? Which is what? -1. You do not tell me 1, you tell me -1 because I asked your value. I did not tell you where. Where you can give me coordinates, right? That's probably where is probably best to ask coordinate, or they say where the x, then you write down the x. So really important, pay attention what the question is asking. That's why you guys need to learn to annotate things. But this is the critical numbers, and this is the critical numbers, right? So critical numbers. Sorry, I'm gonna just erase that. Forget that. Now there are sometimes they can fake situations, which is this situation. I think most of the kids cannot find a critical number here, so we're not working about finding intervals. You can do that for your homework, which is 2x minus 3x to the 2/3. And between -1 to 3 here. Now, this one, I only want you to find critical number. But unfortunately, since I didn't teach you, not because I underestimate you, is because I didn't teach you, you probably cannot find the right critical numbers. I'm going to teach you afterwards, after you try. and you're gonna pay attention on where is a possible mistake happen. What time we get off here? Huh? Okay, I'm gonna go ahead and find that for you. The reason why you only can find, you cannot find all the critical number because they are 2. Yep. That's okay. You got a 1 is because I didn't teach you. I'm gonna teach you now. This derivative is 2, right? Minus 3 to the 2, 3. And the x to the negative 1/3. Does that make sense? And that's equal to 2 minus 2x to the negative 1/3. Now, I was writing like this. Now, when you have this kind of case, like, oh, 2? Yep, 2 is here. Good question. Good job. So there was a 2 here. So what happened? You have done something like this. The reason why you didn't find 1 or 2, you're supposed to find you're supposed to find 2 critical number in this case, because here I will combine fractions. Combine fractions, right? Why does the combined fractions important? Because here it's going to be 2x to the 1/3 over x to the 1/3. I multiply x and 1/3 top and bottom. And minus 2 over x to the 1/3. So therefore, it's going to be 2x to the 1/3 minus 2 over x to the 1/3. Now, you have a numerator and denominator now. So it'll be 2x to the 1/3 minus 2 is equal to 0. X is equal to 1 in this case. You got x 1/3 equal to 0, x equal to 0. So you got 2 critical number here. So those are the things that you should pay attention to. Again, x, y, negative 1, 3, 1, sorry, 0, 1. I'm just going to give you the value here, negative 5, 0, negative 1, and negative 0.24 estimation. You need a calculator with that. So this is absolute min, and this is absolute max. And that's the only thing that you might get confused on when you stuff like this question. Unfortunately, there's only one example here, but also something to tell you is this is called a cusp warning. So when you have even over odd power, so they are a cusp. Okay, so that's something that I would like to tell you. We're going to talk about one more thing before we go. We have 4 minutes. Hopefully we can get done. It's called rules theorem. And you guys are going to have whole worksheet on this. So rules theorem is very, very easy. First, f is continuous between 2 intervals. And this is a closed, which is including the endpoints. The endpoint has to be a solid dot, cannot be an open circle. 2, f, this is f of x. So we're going to say f of x is differentiable. It's open parenthesis a and b. The reason being is that endpoint is not differentiable. So therefore, it's now point to including a and b. It's no point to have an endpoint. 3, f of b is equal to f of a. And you're going to say, okay, if you have these conditions, this is the conditions, right? And result is this. It's f prime c is equal to 0. Not undefined, but 0. There is at least one c. Now, why? I'm going to ask you to go remodify this word a little bit. I'm going to use a different color to write down the O. the rules theorem to help you memorize is this O. That means f prime of c is equal to 0. So that way you can build a connection between two. Now, what is that saying? That's saying A and B has to be the same height, right? Does that make sense? They has to be continuous and differentiable. The easiest function you can think of is a straight line. Guess what? At every single point here, f of c is equal to 0. The slope is equal to 0. But you don't have this function like that all the time. Sometimes, now, why isn't it differentiable? You think about differentiable, right? That means no cusp. No cusp or sharp turn. So you cannot have a function look like this because nowhere in A and B where derivative is 0. It's actually there was a positive number, there was a negative number, and there was undefined, but there was no 0. So the only time that you can get is probably something like this. A simplest one like this. Guess what? You have a C here is f prime of c equal to 0. Does that make sense? You have a horizontal tangent, right? Or you can have something like this. Can I have more than one? C1 and C2. So they say at least one. So if something like this, you must have this. So all you gotta do is take a derivative set equal to 0, but you gotta make sure the function is differentiable. That means no cusp, no sharp turn. Continuous, make sure no vertical asymptote and no holes and stuff like that. So most of polynomial are no vertical asymptote and no holes. Okay.